Hey, what is good, everybody? Welcome back to the channel. In today's video, we have something pretty beautiful to take a look at. So what I have right now, actually, you know what? Wait. Just give me 2 minutes. Well, not 2 minutes, just 2 seconds. Where is that code? Where are you? Just give me a moment. Just give me a moment. Almost there. Just forgot where it's located. It should be right here. Okay, we got it. So let me just add two extra zeros right there, and then we rerun this. And yeah, now I can start with my question. All right, beautiful. So, if I were to ask you, how many quads or texture atlases do you see on my screen right now, or do you think I'm actually rendering in this instance? If you guessed it correctly, then well done. But it's not 200. It's actually 40,000. So if I zoom out, you'll notice that I have 40,000 different texture atlases. Well, not different texture atlases, but the same texture atlas rendered 40,000 times visible in the engine. So as I zooming out pretty slowly, but you can see that we actually do have indeed 40,000 texture quads rendered at once. And the beautiful thing about this is that we actually rendering this in one draw call. So if we just, what is going on here? Xcode is doing some weird stuff where I have two instances running, but the other one isn't running, but the other one is running. I just do not understand. And it also creates multiple windows, which kind of messes up with its debugger for whatever reason. So yeah, so now we're back, but now it creates multiple windows again, which is something that I really hate. But anyway, if you look at this frames per second that we have right here, we have 60 frames. We literally just maintaining a whole 60 frame per second frame rate with these 40,000 different textured quads rendered on the screen. I keep saying different, they're the same texture, but the quads are 40,000. All right, and this is all possible because I'm using instance rendering, and you can notice that my frame per second is actually just maintained at 60. It's like literally just locked at 60. There's literally no bottlenecks right now. I can zoom in and out as much as I can, whatever, everything is fine. Okay, and you notice that I have memory increments right here. That's just because we have memory leaks per frame, so do not entertain that because I'm very well aware of that. So we do have memory leaks, which is fine. But yeah, so what I'm gonna do now is just close this and go back to the engine and then just decrease this back to just 4. Because I just wanted to show you guys something really cool. Anyway, so yeah, so let's give you a tour of what I've worked on and what you guys are looking at exactly. So what we're seeing here is actually 4 different things rendered on the screen. We have textured quads that are using instance rendering. We have UI, font UI, right, basically being rendered. Text UI text being rendered. What is the proper terminology here, guys? I really do not know. But anyway, we have text UI rendered on the UI layer, and you can see there's some defects here or artifacts or something is wrong. Something is off. It looks okay at the beginning, but as you go and read deeper, you notice some sloppiness, and that's due to the fact that I'm manually calculating the current offset. I do not know if that's something I should be doing, because if you look at the texture atlas, right, let me just zoom into one of these, you'll notice that the way that this is packed, each element actually is well aligned properly, right? So what is it that I'm doing that is resulting in this messy stuff right here? Honestly, I do not know, because the solution that I have, and again, I'm going to show this because I'm pretty sure someone smarter than me is watching this right now, so hopefully you guys can tell me what I'm doing wrong. Yeah, you guys gonna get some of my code if you're lucky. But anyway, this is my draw UI text code, and you'll notice that at the bottom here I have kerning offset set to 0, and then per character I'm checking if it's R. If it's R, just offset the next character by 0.1 before you render it. Yeah, and you're gonna start to see that this kind of gets a little bit tricky down the line because certain letters do not need a kerning offset, and certain of them just need you to pull them in, which I think defeats the whole purpose of a kerning offset. I really don't understand. So that's something that I'm doing, and certain elements or texts or characters need to be basically pushed down or up because they don't look good when rendered with capital letters next to them. So we have to offset them to basically align on the same baseline or something like that. Again, I'm doing this manually, which again, I do not think is the way to go about that. So if someone smarter than me is actually watching this right now, please let me know what it is that I'm doing wrong and what it is I need to do to actually fix this, because the way I'm receiving the font data is from the MSDF font atlas generator, which is this right here on GitHub. And what it does, it generates a font atlas, which is this guy right here, and it also generates a font data file, which basically contains the position of each element on that texture, of each character on that texture, and its offsets in pixels or whatever it is that they're using, the measurement units. And then what I'm doing is I'm taking that file that they give me, I settled with JSON because it just had more data that I could read with my eyes and understand with my eyes, and then I'm parsing this in my engine. So in my engine I have a custom JSON parser which I built, so it just parses JSON. It's pretty simple, it's pretty lightweight, it just parses JSON, and then I can basically have that font data rendered, font data, and then I can basically construct my glyphs. So that's what I'm doing for the UI, for the text or the font rendering situation. Now again, if anyone smarter than me is watching and can see my mistakes for what's going on here, please let me know in the comment section and just help me out or give me resources I can look into, because I'm doing this from scratch on my own. I really do not know the best methods. I'm just experimenting and learning as I go. So enough about the text. So let's talk about the UI elements. So what I have here is a column which has 3 elements, and then each element can respond to mouse events. If I hover, you can notice that it changes the background color, and then if I get out of there, it changes back to normal state. And then the same would happen for this button, and the same would happen for this button. So ultimately all the buttons in this container essentially respond to mouse input. I can click on each button and a specific action can happen, but at this point nothing happens because I didn't really hook these buttons to do anything, but the logic to handle mouse clicks is there, and actions is there. All right, so that's what's happening. And then this container itself is actually a layout config. So if I go back in my engine and I just go to where I'm defining that specific container, it's right here, actions container. So all the elements are currently displayed in a column form. So if I wanted to display them in a row, I can just say Nova row, and Nova is actually the UI layout system, the name of my UI layout system. So if I just essentially run that again, you'll notice now instead of it being in a column, it's now in a row, and then the spacing and everything is still there. If I remove one button from there, so if I just maybe comment out this code that adds the 3rd button, you'll notice that the container also resizes to basically match and fill the width and height based on the elements that are inside. So that's my UI system right there. It's pretty simple, pretty rudimentary. It's just really inspired by CSS and how CSS works. So that's what's happening here. And then these 2 guys are just geometry to basically let you understand what's going on here. So what we have here is a rectangle, and then on top of that is a border, which is just simply just a separate piece of geometry that is just slapped on top of the rectangle. And then we have the corners basically synced up with the rectangle below to basically give the illusion that we have a bordered rectangle. Sorry about that. So if I show you the code, if I go down to where I am actually rendering all of this, you'll notice that this one right here is the code for is the function call for the pink border that has no rectangle inside. That's just hollow. So if I now say something like I don't know, border, let's just do border top. So if I give a flag, what's going on here? Oh, that's in the wrong location. So if I give a flag here of border top, you'll notice now I'm telling it to just draw a border on the top, not throughout the entirety of the shape. So now we have border on the top. So if I wanted to, this button could only just have a border on the top instead of having it all the way around it, right? And then I could also maybe perhaps say, instead of top, we can say border maybe bottom, for instance, and then it'll just draw the border at the bottom, right? So these are the customizations that we can have in terms of borderness. And then another cool feature that we have also is if I had to say, let's just say border top, and then we go border bottom. Let's just activate the entirety of this, and we do left, and then we do border right. I think we have all edge cases. So if I rerun this, it's just to give you the same illusion as we had before we added these flags, right? It's just that now we're adding customizability to it. So now if I add another argument here, and then I do corner top left, so I selected the corner top left, and that one will be the only one that is rounded. So corner top left is this corner right here, and notice that it's curved, and then these ones are not. That's because using this flag we can control which corners are actually rounded up, right? So I can say corner left, let's say bottom, let's say corner bottom, let's do right, and then if I rerun this, we're gonna have this one rounded off and then these two are not rounded off. So that's the customizability that we have in terms of border roundness, and this applies to the normal rectangle as well. Even if it's not bordered, it should have functionality to also just be rounded off on a specified corner, but actually it's not yet supported for the rectangle. It's just supported for the border geometry itself, but I am gonna add it to the rectangle. I don't know if I should, but I'm gonna add it actually so that it can basically conform with this and actually work with this, especially for custom UI elements that I want to have a specific look and feel in my engine. I do want to have this granularity or this level of control, I guess. So yeah, and then lastly I have this HSV component. Now this is something that I was experimenting with. I wanted to see, can I make my own custom color picker in my 2D renderer for UI, and it turns out that I can of course, and it's really not that hard, although it's actually using its own draw call. That's because it's using a different rendering technique as opposed to these guys. It's because it's isolated from these guys. It's not badged with these guys. It's actually drawn on its own separate draw call. It's just fine for now because I just wanted to test and see if I can actually draw this type of thing and actually render a fragment shader that actually shows HSV color wheel, and it turns out it is possible. It's not interactable, but you can basically see how you could easily add functionality to essentially support what is this again, add support for color wheel and color picking, etc. So my memory, you know why this is happening? We have memory leaks in my engine, and I feel like they've just accumulated to such a level that it began to become slow. So if I just stop this, it should just clear out the memory and free out my system, and now it's back to being responsive again. So if I run this again, we should be fine because my system was slowing down for whatever reason. Yeah, I do have memory leaks, but yeah, everything is now back and working again because we reset that. So that's the UI library system that we have here, and we do have artifacts, especially when it creates a window and it doesn't give the UI itself time to recalculate stuff. It just starts recalculating at weird offsets that I do not understand. So that's why we have this extra padding on this end. There are subtle artifacts that still need to be fixed and worked around, but other than that, everything else works as it should work, and I'm actually proud of this. So if you guys want me to go create videos on how I did 1, 2, and 3, or how I approached the UI layout system, let me know, and I'll make maybe a tutorial or something, or a breakdown or something, and share it with you guys. So my code base is C. And I know I showed you guys some magic here by introducing arguments without basically redefining my function name here. And we know that C doesn't have function overloading, but if you actually check, it actually does. And I learned this through Apple's documentation and Apple's sample code. It actually does. It's actually a Clang macro or a Clang function. Clang compiler thing. I don't know what's the right terminology for that anyway, but it actually does. So if you look here, that's the function that I was basically basically modifying. So it has the same name as this one and as this one, but each one of them have different parameters. So that's how I can basically do that. So this one has corner flags and border flags, whilst this one only has border flags, whilst this one doesn't have any flags. And it's all possible through this little macro here called overload. I actually named it overload, but you can call it whatever you want. And all that's doing is essentially just calling this attribute overloadable thingy right here, preprocessor, whatever you call this. I really do not know. Yeah. So this is only supported in Clang. I do not know about GCC compilers, but yeah, that's how you would achieve the same results as I have right there. So yeah, hopefully you learned something new today if you didn't already, and I'll see you guys in the next one. Cheers.